Today we are going to start the physics for class 10 CBSE. The chapter is electricity. You are all familiar with the word electricity. Now, first of all, what is electric current? Electric current, it is the rate of flow of charge. It is the rate of flow of charge. Here we consider charge as the electrons. So actually what happens? A conductor, you can take a copper or an iron or an aluminum. They are metals. These metals are conductors. So these metals, you all know that they have free electrons because their atomic number, they are of higher atomic number, and so they uh, have free electrons. Free electrons does not mean that they get separated from the surface of the metal. They remains on the surface of the metal, and when a potential difference, that means the potential difference is usually applied by a cell or by battery. When a potential difference is applied across the conductor, the electrons starts to flow towards the positive terminal. So the rate of flow of charge is called as electric current. Now here we see that the electrons flow from the negative terminal to the positive terminal, but we consider the direction of the current from the positive terminal to the negative terminal, because we know that energy flows from an higher energy to a lower energy. So it may be considered as the flow of positive charge. It may be considered the flow of a positive charge as the flow of the current. So the direction of the current is opposite to the direction of flow of the electrons. I am going to explain it in a very simple manner. Now, so from here, rate of flow of charge. So rate means time. So I is equal to Q by T. I is equal to Q by T. It is the rate of flow of charge, and it is called as electric current. So if Q in SI unit, Q is in coulombs and time is in second. So coulomb by time, this is a ampere. The unit of current is ampere. So if 1 coulomb is charged, is flowing through a given cross section, if 1 coulomb of charge is flowing through a given cross section of a conductor in 1 second, then we say that 1 ampere of current is flowing through it. So 1 ampere is equal to 1 coulomb by 1 second divided by 1 second. And it has other unit of ampere, that is the smaller unit, that is 1 microampere is equal to 10 to the power of minus 6 ampere, and 1 milliampere, that is equal to 10 to the power of minus 3 ampere. So this is all about electric current in a simple manner. I have explained you. Now next comes your potential difference. Potential difference, that is the potential difference, that means the free electrons, for the flow of the free electrons in a conductor. For the flow of the free electrons in a conductor, an external means there must be a potential difference between the two ends of the conductor. Then only the electrons will flow, then only the flow of the electron is possible. So now here, that means to flow the electrons from one end of a conductor to the other end, you have to do some work. So the work done to move a unit charge from one point of a conductor to another point, that is called the potential difference between the 2 points, or you can say the potential difference between the two ends of the conductor. So it has been clearly stated that the work done in moving the electrons, in moving a unit charge, that means work done to move a unit charge from one point to another point in a conductor, or from one end of the conductor to the other end, is called the potential difference between the 2 points or the two ends of a conductor. In an electric circuit. So you can state it as potential difference is equal to work done by charge. So you know that in SI unit, work done is in joules and charge is in coulomb. So 1 volt is the unit of potential difference is volt, and 1 volt is equal to 1 joules by 1 coulomb. That means if 1 joules of work is required to move a unit charge from one point to another point, or from one end of a conductor to another end, then we say that the potential difference across the two ends, or across the 2 points of a conductor is 1 volt. So now I think so you are clear with the definition of potential difference and what is the potential difference. That means ultimately you can say that potential difference is nothing but it is the work done. It is also a work done. Means to work done to move a charge from one end of a conductor to another end. Now this is all about the basics in class 10, only the basics are given. So this is all about the electric current and potential difference. Now we come to the Ohm's law. What is Ohm's law? This is a very important law, and according to the Ohm's law, at constant temperature your potential difference is directly proportional to the current flowing um, in an electric circuit, or your potential difference is directly proportional to the current flowing through a conductor, you can say like this also. So when V is proportional to R, and if when you remove the proportional sign according to your mathematics, there comes a constant, and this constant is called the resistance of the conductor. So V is equal to IR. R is the resistance of the conductor, when R is the proportionality constant, and we called it the resistance of a conductor. That means what does the resistance of a conductor do? The resistance of a conductor retards the motion of the electron. So it retards the flow of the current. So this is the work of a resistance. And in SI unit, the unit of resistance is ohms. Now here resistance, now you are familiar with the word resistance, and what does a resistance do? So there are three types of materials. One which allows the flow, metals and alloy, they allow the flow of the current, that is they have low resistance, whereas your insulators, they have high resistance, they retards the, that means they retards the flow of the electrons. That means you can say that insulators current can't pass through an insulator. So here Now we come to the point that resistance, where what resistance depends on. Resistance, it depends on the length of the conductor and cross-sectional area of the conductor. So the resistance of a conductor is directly proportional to the length of the conductor and is inversely proportional to the cross-sectional area. In between, I want to tell you something about Ohm's law, that if you draw a graph between potential difference and current, taking potential difference in y-axis and current in the x-axis, you will get a straight line. So now we come back to the resistance. The resistance of a conductor, it depends on the length of the conductor and also the cross-sectional area of a conductor. That is, resistance of a conductor, it is directly proportional to the length of the conductor and inversely proportional to the cross-sectional area. So R, capital R, is proportional to L by A. Now again, as per maths, when you remove the proportional sign and instead of proportional you are going to place equal to, so R equal to some constant, that constant is considered as rho. So R equal to some constant, that is rho L by A. So rho, it is called the resistivity of the material. So resistivity of the material, it is the property of the material, and it is the property of the material. Now, resistivity of a material. Resistivity of a material, it is the property of the material. And the resistivity of metal and alloy are lower, and it is most probably in the range 10 to the power of minus 8 to 10 to the power of minus 6 ohms meter. The unit of resistivity is ohms meter. So here your resistivity of metals and alloy are low, and it is in the range 10 to the power of minus 8 to 10 to the power of minus 6 ohms meter, whereas resistivity of insulators are high. Resistors of insulators are high. Now you have come to know that the resistivity of metals and alloy are low, but the resistivity of the alloy is higher than its constituent elements, and alloy are used as heating elements because they do not readily get oxidized. That is why alloys are used as heating element. And in our electric bulb, your filament of an electric bulb is made of tungsten. Now these all things I have is now outdated, especially the filament of an electric bulb is a tungsten. These are outdated today because now they, instead of this filament bulb, it has been replaced by all LED lights. So earlier your bulbs where filaments were fitted in the bulb, and these filaments were made up of tungstens because it had high temperature. Now, because it melts at a very high temperature, above 3000, most probably above 3000 degrees Celsius. Above 3000 degrees Celsius, it has a high melting point, so the filaments of the bulbs were made of tungstens. But today these are outdated because it has been replaced by LED lights. Now we come to the, again, both resistance and resistivity both depends on temperature, but there is a difference between resistance and resistivity. Resistivity, it is the property of a material, but resistance, that means it is the property of a material. If you take iron, whether it is of a length of 2 centimeter or 5 meter, its resistivity is same. but your resistance will differ, because you know that the resistance, it depends on the length. It's directly proportional to the length of the conductor and inversely proportional to the cross sectional area. So if your length increases, your resistance increases, and if the cross section of the conductor increases, your resistance decreases. Now we come to the connecting resistors either in series or in parallel. If the resistors are connected in series, what happens? And if the resistors are connected in parallel, what will happen? So when the resistors, they are connected in series, the most important point, that means when you are connecting in series, you will complete a circle. That means circuit, when you are going to complete a circle, remember this point. It's a very important point, that ammeter is always connected in series. The resistors, when they are connected in series, you remember that the most important point, when the resistors are connected in series, the current flowing through it is constant. The most important point here is the current flowing through it, the resistor is constant when they are connected in series. So the total resistance of the circuit will be the sum of all the resistors. Sum of all the resistors. So suppose if three resistors are connected in series, so the total resistance capital R will be equal to R1 plus R2 plus R3. Whereas in parallel connection, when the resistors are connected in parallel, here the most important point is that the potential difference across the each resistor remains, the current remains constant. The potential difference across each resistor remains constant, but the current flowing through different resistor is different. As per the requirement of the current of the electrical gadget, the current flows through it. This is a very important point in parallel connection. And in parallel connection, the total resistance becomes 1 by R, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So from here we can conclude that in parallel connection, the total resistance decreases, but in series connection, the total resistance increases. Now, there are some, it is impossible for us to connect a bulb with a heater or a room heater in series, but this is possible in parallel connection. That is, in parallel connection, your potential difference is same, but here, as per the requirement of the gadgets, the electrical gadgets, the current flows through it. This is the very important point in Ohm's law. Here, in Ohm's law, you find that your potential difference remains the constant, but you can vary. The current flowing through it by the help of a resistor. You can vary the current flowing through it by the help of a resistor, and such type of resistors are called rheostat. That means here also the same phenomenon. Here you see the potential difference across the resistors remains the same, but the current flowing through each resistor is different. And the parallel connection in our house, you will find that it is a parallel connection. Only the series connection, it is found in the fancy bulbs which we use to decorate our homes in Diwali or in any celebration. Here the bulbs are connected in series, but in our household the connection is a parallel connection. Now our next topic goes to the heating effect. That means you might find that whenever a fan is on for some time, if you touch its body, you find that it gets heated up. So that means your electrical energy, some part of the electrical energy is converted into heat energy. Now you see that what is power? Power, it is the rate of work done, that is W by T. And now what is W? Your W is equal to V into Q, potential difference into Q, which you have learned earlier, that the potential difference across the 2 points is equal to the work done by Q, that is to move a unit charge from one point to another point, the total work done, that is the potential difference across the 2 points. So here work done will be equal to V into Q. Now power, that is equal to W by T, and in place of W, if you place VQ by T, then again Q by T, it becomes current. So power is equal to V into I. This is how the formula of power, electrical power, is formed, that is power is equal to V into I. Now, what happens here? That means the sum of the electrical energy is converted into heat energy. So that means power into T, that is the energy. So power into T, that is the energy, that is the heat energy formed, that is the heat energy formed. Now here your power is Vi. So in place of P, if you place V, it becomes VIT. So that is equal to H. Now instead of V, if you place IR, the H becomes I square RT. This is called Joule's law of heating. That means when current flows through a conductor, there is a heating effect. That means a part of the electrical energy is converted into heat energy. Now here we come to the another topic, that is fuse. What is a fuse? Fuse, this is an important part of an electrical gadgets or household. The fuse here, what happens, it takes the help of the Joule's law of heating effect. Now, if there is a high flow of current, then the due to the heating effect, the fuse, it gets melted and the circuit is disconnected, by the help of which your electrical gadgets remains safe, or your household connections remains safe. So fuse, it is nothing but a portional, it is a portional made of porcelain, and it has two metals attached on the upper end and the lower end, and a fuse wire, it is a metal wire, it is connected to the two metals. But today, this, instead of this fuse, here MCB are used. So these were earlier in our household, you will find that there is a fuse box where fuse are used, but today in place of it MCB are used, and that is the function of a fuse. It is, but still you will find a fuse in electrical gadgets such as in inverters or UPS. You will find that a fuse is fitted. It is it consists of a glass tube with two metal heads fitted at the two ends, and inside it you will find a thin wire connecting the two metal heads, which act as a fuse. So this is an important part. And at the last of all, we are going to the going to this power. What is power? Which you have already I have told you that power, it is the rate of work done, and P is equal to VI. So it has different formulas. Instead of V, if you place IR, then P is equal to I square R, and instead of I, if you place V by R, then P is equal to V square by R. So there are three different formulas of power, and the unit of power is watt. but there we use higher unit of power, that is kilowatt, and 1 kilowatt that is equal to 1 kilowatt that is equal to 1000 watt. Now, you remember that the unit of electrical energy is watt hour or kilowatt hour. Remember, this is unit of electrical energy. This is kilowatt hour or watt hour. Now, 1 kilowatt hour that is equal to 1000 watt into 3600 seconds. So this comes to be 3.6 into 10 to the power of 1000 and 3600. That means 3.6 into 10 to the power of 6 joules. So this is the relation between 1 kilowatt hour and joules. That is 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. So this is all about your in this topic it is given to you about electric current, and in your new syllabus some of the topics has been deleted and only the basic of the electric current is given to you. Now my next topic is on reflection, that is about light, reflection and refraction for class 10 CBSE. This same course is also applicable in SEBA. So yes, in SEBA, that is that's the board of Assam. So here my topic is light, reflection and refraction. You must be familiar with the word reflection. If you take a plain mirror, then when a light falls on it, the lights get reflected after striking the plane mirror, the reflecting surface of the plane mirror. Here we consider the light as a ray, because to draw the ray diagrams it is easier to take light, consider light as a ray. You can make a light ray, that is you take a candle or a torchlight and let it pass through a cardboard where there is a pinhole, a cardboard with a pinhole, and if you let a light or a candle light or a torch light pass through it, you will get a ray of light. So when a ray of light falls on a plane mirror, that is on the strikes the surface of a plane mirror, it gets reflected. So this is about reflection. And here when the light ray, when it strikes the surface of a plane mirror, the point at which it strikes the surface, that point is called the point of incidence, and from the point of incidence the light get reflected back to the same medium. And at the point of incidence, if you draw a perpendicular to the mirror, at the point of incidence, if you draw a perpendicular to the plane mirror, then that perpendicular is known as the normal. The angle between the incident ray and the normal is called the angle of incidence, and the angle between the reflected ray and the normal is called the angle of reflection. Now, here there are two laws of reflection. That is the first law, it is the incident ray, the reflected ray and the normal at the point of incidence lie on the same plane. And the second law is that the angle of incidence is equal to the angle of reflection. This is all about plane mirror. But in your course, it is the stress is given to spherical mirrors. So spherical mirrors, that means you consider a hollow sphere, and if you cut a portion of it and remove it, you will get a curved surface, curved surface, say like that of a spoon, the spoon surface, like that of a spoon surface, you will get a curved surface. You will get a curved surface, and if you color the outer surface and your inner surface is a reflecting surface, then it is called a concave mirror. And if you color the inner surface and your outer surface is a reflecting surface, then it is called a convex mirror. Now, since this curved surface is a part of a sphere, so the sphere has a center, and this center is called the center of curvature. And the midpoint of the mirror is called the pole of the mirror. Now an imaginary line passing through the center of curvature and the pole of the mirror, that imaginary line is called as the principal axis. Now what happens, let us take the case of a concave mirror. Here the concave mirror, what you will find, here your reflecting surface is the inside portion. The inside portion is your reflecting surface and the outer portion is colored. So the inside portion is the reflecting surface. Any line coming parallel to the principal axis gets reflected and it passes through a point, or you can say it intersects at a point on the principal axis. That point is called as the principal focus. So remember that any light ray coming parallel to the principal axis after reflection passes through or intersect at a point on the principal axis, and that point is called as the principal focus. Now the distance between the center of curvature and the pole is called the radius of curvature, and the distance between the focus and the pole is called the focal length. Now there is a relation between the focal length and the radius of curvature. Your focal length is equal to half of the radius of curvature. And next, any line which is passing through the focus after reflection, it comes parallel to the principal axis, and the ray which passes through the center of curvature, it returns back in the same direction. These are the uh, these are theories used to draw the ray diagrams for a concave mirror. Now here the mirror, there are two types of images are formed in a mirror. In a plane mirror, you must remember the plane mirror always produces virtual image, and the object distance is always equal to the image distance. But concave mirror and convex mirror, here also images are formed. Now that is the two types of image, that is the real image and virtual image. What is a real image? When the reflected rays actually intersect at a point, at that point your image is formed. And in virtual image, when the reflected ray appears to intersect at a point, then a virtual image is formed. So remember that when the reflected ray actually intersect at a point, you get a real image. That means the real image can be collected on a screen. And in virtual image, when the reflected ray appears to intersect at a point, you get a virtual image, and here you can't collect the image on a screen. This is the difference between a real image and a virtual image. So similarly, in case of a concave mirror, you get a real focus, but in case of convex mirror, you get a virtual focus. Because your concave mirror is a converging mirror, the light ray which comes parallel to the principal axis, they all the after reflection, they intersect at a, all these reflected ray intersect at a point on the focus, on the principal axis, and that point is called as the principal focus. Whereas a convex lens, it is a convex mirror, it is a diverging mirror. So here the light reflected ray appears to intersect at a point, and that point is called the focus, which is, you can say, it is a virtual focus. And in case of a convex mirror, you are always going to get a virtual image and a size smaller than the object, and the virtual images are actually found behind the mirror, whereas real mirror image can be, you can locate it, you can collect it on a screen. Now here the image formations. This the ray diagrams which you must practice. First of all, I am going to tell you all the positions. That is, if the object is placed if the object is placed away from the center of curvature, if you place an object away from the center of curvature, you are going to get an image in between the center of curvature and the focus. The size of the image will be it will be inverted, diminished in size, and you are going to get a real image. If you place the focus on the center of curvature, you will get an image on the center of curvature. It will be real, inverted, and equal in size. And now again, if you place the object between the center of curvature and the focus, you are going to get an image away from the center of curvature, and it is a real image, inverted and magnified. And third, if you place the object on the focus, you are going to get an image at infinity, which is a real image, inverted and highly magnified. And the last case, if you place the object between the focus and the pole, you are going to get a magnified, erect and virtual image behind the mirror. So in concave mirror, this is the only one condition where you are going to get a virtual image. That is, when you place the object between the focus and the pole, you are going to get a virtual image that is virtual, magnified, highly magnified and erect. Now this is all about your mirror. And your concave mirror, it is usually used by dentist or by your saving mirrors, where you can get a highly magnified image. And it is also used by in torch lights, where the rays after reflection, the rays comes out parallel to the principal axis. And the convex lens, here convex mirror, here the convex mirror, it is used as the rear view mirror in your motor vehicles. The rear view mirror, because it gives an erect, its image is always erect, but it is diminished in size, yet it is used as rear view mirror instead of plane mirror, because plane mirror also gives virtual image. Instead of plane mirror, we use a convex mirror. The most important point here is that the convex mirror, because of it is bulged outward, it covers a maximum area, and it becomes the rider to view the rear image, all the rear image. So this is all about your spherical mirror. Now I am going to refraction. So what is refraction after all? So here refraction, that is when light ray moves from one medium to another medium, the light's ray gets bent. Instead of moving straight, it gets bent. So this bending effect of the light ray when it moves from one medium to another medium, this phenomenon is called refraction. You will, because of refraction, that is, if you place a coin inside a glass filled with water, if you look it from the above, you will find that the coin is lifted above. All this is because of the refraction. Now here you must remember that when the incident light means there is refraction takes place at the interface between the two surfaces. So there are two types of surfaces. One is the rarer medium and another. There are two types of medium. One is the rarer medium, another is the denser medium. Rarer medium, it wants to say that it is optically rarer, and denser medium, it means that it is optically denser. That means in rarer medium, the light travels faster than in the denser medium. So when a light ray moves from the rarer medium to the denser medium, the refracted ray gets bent towards the normal. So here your angle of incidence is greater than the angle of refraction. But if the light ray moves from the denser medium to the rarer medium, the refracted ray gets move away from the normal. So in this case, the angle of incidence is smaller than the angle of refraction. So from here, there are two laws of refraction. First is that the incident ray, the refracted ray, the normal at the point of incidence lie on the same plane. And the second law is that sine I by sine R is a constant, and that constant is called the refractive index of the medium, and it is known as the Snell's law. Now here another definition of refractive index, that is if a light ray coming from air enters into a glass slab, then the refractive, we say that if a light ray, remember the refractive index is considered where the light ray enters. The refractive index is actually considered where the light ray enters, that the light ray in the medium in which it enters. So the refractive index, if suppose a light from the air enters a glass slab, that means we say that the refractive index of glass with respect to air, that means light is coming from air and it is entering into the glass slab. So we say that the refractive index of glass with respect to air. So this is equal to the velocity of the light in air divided by the velocity of the light in the medium, that means in the glass slab. So similarly, instead of air, there can be water. So if we take two mediums, water and glass, and suppose the light is coming from water and entering into the glass, we say that the refractive index of glass with respect to water. So remember, the refractive index is actually considered the medium in which the light enters. So we say that the refractive index of glass with respect to water, so that will be equal to velocity of the light in water divided by the velocity of the light in the glass. Now let us come back to we are considering the rarer medium as air, and a denser medium, it may be glass, water. So now if the light is coming from the air and it enters into another denser medium, so we say that let us take air and glass. So refractive index of glass with respect to air. Now in this case, it will be equal to the velocity of the light in air, which you can consider as velocity of the light in vacuum, divided by the velocity of the light in the medium, that is glass. So this refractive index is called as absolute refractive index of the glass. If the if in any medium, if the light is coming from air, then we say that it is the reflective index of the medium, absolute refractive index of the medium. Now, the most important point here is that this refractive index help us to determine what will be the velocity of the light in the given medium. And you know that the velocity of the air, it is considered as the velocity of the light in vacuum, that is equal to 3 into 10 to the power of 8 meter per second. So this is all about refractive index. And there is one more point: when a light moves from the denser medium to the rarer medium, the light gets refracted away from the normal. Here angle of incidence is small than the less than the angle of refraction. Now we increase the, this happens where only when the light moves from denser medium to the rarer medium. Now let us increase the angle of incidence. You will find that at some angle of incidence the angle of refraction is 90 degree. You will find that at some angle of incidence your angle of refraction will be 90 degree, and such angle of incidence is called as the critical angle. If you increase the angle of incidence greater than the critical angle, the refracted ray gets there is no more refraction, there takes place reflection. That is, the light gets reflected in the same medium. No refraction, reflection. If you increase the angle greater than the critical angle, then there is no more refraction in here. Reflection takes place. The total, that means the light get reflected in the same medium, and such type of reflection is called total internal reflection. And such reflections takes place, such a phenomenon is used in optic fibers. The most important point here is that in total internal reflection there is no loss of energy. Now we shift to the spherical, now we shift to lens. So these two lenses, there are in your textbook only two type of lenses are given to you. One is the convex lens, another is the concave lens. In convex lens, that means how lenses are formed. These lenses are formed when two solid spherical glass sphere, if they intersect, they forms a lens. So convex lens is formed, convex lens is formed, and another a concave lens is formed. So in convex lens, because it is formed from two spheres, so it has two center of curvature, it has two focal length, focus, and the center of the lens is called as the optical center, and a imaginary line which passes through the center of curvature, and the optical center is called the principal axis. Now here, there I have left one thing, is that the sign convention in two thing in mirror, that is the sign convention. The sign convention is according to your coordinate axes. Let us consider the pole to be at the origin of the coordinate of axis. The left side is considered as the negative, and the right side is considered as positive, and the upper side is considered as positive, and the lower y-axis is considered as a negative. So your sign convention is according to your coordinate axis. And there is a mirror formula, that is I left here, that is 1 by v plus 1 by u is equal to 1 by f, where v is the image distance and u is the object distance and f is the focal length. So here you will find that here you will find that another important point is the magnification, that is equal to size of the image by size of the object, that is equal to minus v by u. If your magnification is negative, that means it is a real image, where if your magnification is positive, then it is a virtual image. Remember, here magnification m is equal to minus v by u. Now here, from the coordinate axes, you can easily determine that the focal length of a concave mirror is negative, whereas the focal length of a convex mirror is positive. And in mirror we will find that the images are formed on the same side of the object. Now we come back to the back to the lenses. Here what happens, the images are formed on the other side of the lens, that means on the other side of the object. The same thing here happens, that the line yeah, the light rays coming parallel to the principal axis, after refraction it passes through the principal focus, so it intersected on the principal axis at a point, that is the principal focus. And here same thing is here, that is the distance between the center of curvature and the optical center is called as the radius of curvature, and the distance between the focal focus and the optical center, it is the focal length. Now here in case of lens, that is we go to the formation of image. If the object here in your textbook, instead of center of curvature, it is there are two focus, means f1 and f2, and center of curvature are considered as 2f1 and 2f2, because you know that the radius of curvature is equal to twice the focal length. Now, if the object is placed away from the center of curvature, your image will be formed on the other side, that is in between the center of curvature and focus. Your image will be diminished in size, real and inverted. If the object is placed on the center of curvature, your image will be formed on the other side, that is on the center of curvature, and its size will be equal, real and inverted. If you place the object between the center of curvature and the focus, your image will be formed away from the center of curvature, real, inverted and magnified. If you place the image between the focus and the optical center, you are going to get a virtual image. You are going to get a virtual image that is erect and magnified. So this is all about the image formation. But in case of the concave lens, in case of concave lens, because convex lens are convergent, and your concave lens are divergent, here your refracted ray appears to intersect at a point, so you always get a virtual image, and erect and diminished in size. So here you are again, there is a lens formula, that is 1 by V minus 1 by U is equal to 1 by F. And magnification again here is equal to size of the image by size of the object. But here your magnification is equal to V by U. And your last topic is your power. What is the power of a lens? So power, it is the ability to converge or to diverge. So power of a lens, it depends on focal length, and power of a lens, that is equal to 1 by F, and the unit of power in SI is diopter, and the unit of focal length is meter. So here another, again the sign convention, same coordinate axis system. Here your convex lens, since your light rays intersect on the right side, the light coming parallel to the principal axis, it intersects the principal axis on the right side. So here your focal, for convex lens, your focal length is positive. And in case of concave lens, your focal length is negative. So power of the lens, that is equal to 1 by F. In case of if it is a convex lens, so your power will be positive, and in case of concave lens, the power will be negative. Remember that the focal length of convex lens, focal length of convex lens is positive and focal length of concave mirror is negative. So power of a convex lens is positive and power of a concave lens is negative, and unit of power is diopter. And here you can add two different lenses of different powers. If you add two different lenses of different power, and your result if it is positive, then the combined lens will behave as a convex lens, and if it comes out to be negative, then the combined lens will behave as a concave lens.